Hi, welcome to part 2 tutorial video of calculus. In this part, you're going to learn some questions regarding the continuity of a function. So the first question, check the continuity of the function f given by f of x equals 2x plus 3 at x equals to 1. Now, as per definition, f of x is said to be continuous at x equals to c if the limit of the function f of x at x tends to c is equals to the value of the function at c. So we're going to solve this question in just 3 steps. Step 1, we're going to find the limit of the function f of x at x tends to c if it exists. If the limit does not exist, then the function can never be continuous at the given point c. And step 2, we're going to find f of c. In step 3, if the limit of the function f of x at x tends to c is equals to the f of c, then f of x is said to be continuous at c, otherwise not. Okay, so first we're going to write down the function. The function is f of x equals to 2x plus 3, and x equals to 1 means now here x tends to c, right? So x tends to c. So we're going to find whether the function is continuous at x equals to 1. So this 1 is nothing but c value. So c is equals to 1. So step 1, we're going to find the limit of the function. Limit of f of x when x is approaching towards 1. C value is 1, right? So limit x tends to 1. F of x value is 2x plus 3. Now x is approaching towards 1 means it becomes in the place of x we're going to write 1, so it is equals to 5. Now step 2, we're going to find f of c, means the value of the function at c. So c value is 1. So f of 1 is equals to 2 into 1 plus 3. Now we're going to stick to the function, right? This is our function, and in the place of x we're going to write the c value, and the c value is 1. So it becomes 2 into 1 plus 3 equals 5. Now we're going to see the step 3. It says that if the limit equals to value of the function, then the function is continuous at c. So here the limit is 5 and value of the function at c at 1 is also equals to 5. Therefore, since limit of the function when x is approaching towards 1 is also equals to f of 1, therefore we can say that f of x is continuous at x equals to 1. So the next question again, examine whether the function f given by f of x equals to x squared is continuous at x equals to 0. So here c value is 0. Again we're going to write down the function f of x equals to x squared. So step 1, we need to find the limit at x equals to 0, right? So limit of f of x when x is approaching towards 0, which is equals to limit x tends to 0, and f of x is nothing but x squared. Now x is approaching towards 0, therefore it becomes 0 squared equals to 0. And next we're going to find f of c, and c value is 0, so we're going to find f of 0. So f of 0 is here in the x, we're going to write 0 squared equals to 0. Again we see the limit and value of the function at 0 are getting same, right? Since a limit of the function when x is approaching towards 0 is also equals to the value of the function at when x is 0. Therefore, we can say that f of x is continuous at x equals to 0. The next is the modulus function. So we see this one. This one is a modulus function, right? Now Modulus function, let me revise. F of x is equals to, so if x value is greater than or equal to 0, then the f of x value is taking as x. Otherwise, if x is less than 0, that means when x is a negative number, then f of x value will be negative of x. So this is a modulus function, right? Now we're going to find first, as per step 1, we need to find the limit of the function at x equal to 0. So at x equal to 0 means when x is approaching very close to 0. So for this kind of function, the function is splitting at 0, right? When x is slightly greater than 0, we need to take this function. When x is slightly less than 0, we need to take this function. So in order to find the limit of this function at x tends to 0, we need to find left hand limit and right hand limit, and we need to see whether the left hand limit is equal to right hand limit or not. So the left hand limit of f of x when x is approaching towards 0 from the left, 0 negative, right? So 0 here, negative implies x is approaching towards 0 from the left of 0. So limit x is approaching 0 from the left means approaching towards 0 from the left means the x value is very close to 0, but it's a negative number or slightly less than 0. So for that we need to take this function is equals to negative of x. So when x equals to 0, it get 0. Now next one, we need to find f of x, limit of the function f of x when x is approaching towards 0 plus. That means we are finding right hand limit. So when x is slightly greater than 0, that means when x is greater than or equal to 0, we need to take this function. So f of x value will be x. Okay, now we applied limit and we're getting 0. So here left hand limit is equals to right hand limit. So left hand limit equals right hand limit means the limit exists at 0, right? So limit x tends to 0 of f of x is equals to 0. Now in order to see the continuity, we need to find the value of the function at 0, right? So next f of, now here x equals 0 means this 0 is c value, right? So next is f of c. So here f of 0 is equals to, so when x is greater than or equal to 0, we have to take this function x, right? So equals to 0. So that means now see the limit at x tends to 0 is 0, and value of the function at 0 is also equal to 0. Since limit of the function when x is approaching towards 0 is also equals to f of 0, therefore we say that f of x is continuous at x equals to 0. Okay, the next question. Okay, now fourth question, show that the function f given by this function is not continuous at x equals to 0. Now first we are going to find the limit of the function when x is approaching very close to 0, and then we're going to find the value of the function at x equals to 0, and then we're going to compare. Now first limit of f of x when x is approaching towards 0. So when x is approaching towards 0 means not 0 but very close to 0. So f of x function will take this function, right? So limit x is approaching towards 0, f of x will be x cubed plus 3. Now when x is approaching to 0, it becomes 0 cubed plus 3 is equals to 3, right? So the limit is 3. Next is f of 0, right? Next is we need to find f of 0. So f of 0 means f of 0 value is 1 here. When x equals 0, the function value is 1, so it is 1. Okay, now we're going to compare. The limit value is 3 and the value of the function at x equals to 0 is 1. Since limit of the function when x is approaching very close to 0 is not equals to f of 0, therefore we can say f of x is not continuous at x equals 0. Okay, so previous 4 questions we dealt with the continuity of a function at a particular point. So we have checked whether the function is continued at x equal to 0 or the function is continuous at x equal to 1 or 2, so on. Now the next definition is the continuity of a function. So a real function f is said to be continuous if it is continuous at every point in the domain of a function. Suppose this is our function, okay, y equals to f of x. Okay, now this is the function is defined in a to b, right? So from a to b, the function is defined. Now we need to check whether this function is continuous or not. Graphically, we can easily understand this is continuous. Now f is said to be continuous in the closed interval a comma b if this function is continuous at every point in the domain. So f is continuous at every point in the domain a comma b, and also it should be continuous at the endpoint. So the function f of x should be continuous at x equals to a, and also it should be continuous at x equals to b. So f is continuous at the endpoints. If these two conditions are satisfied, we can say that the function is continuous. Now, how can we say that f is continuous at point A? That it's similar like the case before we did for the 4 questions. Okay, now, but one thing you have to keep in mind that since the function is defined from A to B, here this particular point x, when x is approaching towards A, we cannot find the left hand limit, right? There is no sense. So we are going to find the right hand limit, right? When x is approaching towards very close to A from the right, this right hand limit should be equals to f of A. So f is said to be continuous at A if limit f of x when x is approaching towards A from the right should be equals to f of A. Similarly, the function is continuous at point B if the limit of the function when x is approaching towards B. So the limit at point B, okay, now here at point B we can find only the left hand limit. X is approaching towards A from the left, because there's no sense in finding the right hand limit because the function is defined from A to B only, right? So the left hand limit of the function when x is approaching very close to B from the left should be equals to f of B. Then we say that f is continuous at point B. Okay, so let us do now a few questions. Is the function f of x defined by f of x equals to modulus of x continuous? So we need to check whether this function is continuous. So continuous means whether this function is continuous for all x belongs to real number, right? Okay, now this is a modulus function. So a modulus function, we have f of x is equals to, if the x value is greater than or equal to 0, then f of x value will take as x. If x value is less than 0, f of x value will take a negative of x. Now we need to check whether this function is true for all the real numbers, right? In order to do that, we're just going to see, okay, this is our real number, this is 0, right? So we're going to check for 0. So we're going to do it in 3 cases. First, if x equals to 0, then what about the continuity? And then next, when x is greater than 0, so we don't need to check for all the points which are greater than 0. So we're just going to take any number which is greater than 0. And then we're going to check for x less than 0. It means x is negative number. So similarly, we don't need to check for every number. We just arbitrarily, we're going to take one number and we're going to check for that number, whether it's continuous or not. If it is continuous, it will be continuous for all, right? So case 1, if x equals to 0. Now whether the function is continuous or not, we're going to continuous or not at x equals to 0. So this one we have done in a previous question, right? So you can refer the previous questions, and the same procedure is done there. Now okay, we have done same. So if you want to see the function is continuous at x is equal to 0, the procedure is the same as we have did in the previous few questions. Now case 2, if x is a positive number, right? So x is a positive number, means x is greater than 0. So let's let's say take any number, let's say c, which is greater than 0. Now we're going to check for c whether the limit is equals to the value of the function, right? Now first we need to find limit. So limit of f of x when x is approaching towards 0, which is equals to limit x is approaching towards c, right? Now we knew that c is greater than 0, therefore the function should take as x. So x, now we substitute limit when x is approaching towards c, then this x will approach towards c, right? Okay, then next we need to find f of c, and we knew that c is greater than 0. Again, similarly, we need to take this function x, means that is c. Now we compare, this is a limit value, this is a f of c value, right? Okay, since limit of the function when x is approaching towards c is equals to the f of c, right? Therefore we can say this f of x, the function, is continuous for all the positive real numbers, right? So f of x is continuous for all positive real numbers. Okay, next we need to check for the negative real numbers. Let's say case 3, if x is negative real number. So we take arbitrarily, we take any number, right? Let's say take any number c such that c is less than 0. Okay, now we need to check for this c. If it's true for c, then it will be true for all the negative real numbers. So first we need to find the limit of f of x when x is approaching towards c is equals to the limit x tends to c f of x, right? Okay, now here when x is less than 0, then the f of x value will take as negative x, right? So this f of x value will be negative x, now which is equal to x tends to c, so it will become negative c. Okay, next we need to find the f of c, so which is equals to, again, the f of x will be equals to minus x, right? So equals to minus c, right? Okay, now we compare. This is the value of the function at c, this is a limit of the function when x is approaching to c. Again, two values are getting same, since limit of the function when x is approaching to c is equals to f of c, right? Therefore again we say that f of x is continuous for all negative real numbers, right? And one more thing I want to add, that f of x will be here. I want to add here that f of x will be continuous will be continued as x equal to 0. So you can check, right? So uh, so so all these three cases, when x equals to 0, when x is greater than 0, when x is less than 0, the function becomes continuous. Hence f of x is continuous for all real numbers. Okay, now next question. Discuss the continuity of the function f given by f of x equals to x cubed plus x squared minus 1. Okay, so this is a polynomial function, and so for any values of x you put, we will get the corresponding f of x value. So we will get f of x value for any x value. So f is defined for all the real numbers. Okay, now we need to check whether the function is continuous for all the real numbers, because the function is defined. Right now we need to see whether this function is continuous for all the real numbers. So that means we don't need to check for each and every number. We just take any arbitrary number, and then we find the limit and the value of the function, whether they are getting same or not. So first, limit of the function f of x when x is approaching towards c. Let c be any real number, right? Then limit x tends to c, the f of x value is x cubed plus x squared minus 1. Okay, when x is approaching towards c means the all x value will approach towards c, right? So it becomes c cubed plus c squared minus 1. Okay, next is we need to find f of c. So the value of the function at x equals to c, right? So c, it becomes, in the place of x you're going to write c cubed plus c squared minus 1. Okay, now we observed that the limit of the function when x is approaching towards c and the value of the function when x is equal to c, these two values are equal, right? Since limit of the function when x is approaching to c is equals to f of c. Therefore, we can say that f of x is continuous, right? Or continuous for all real numbers. Okay, so this is the last question I'm doing. So this is the last questions about regarding continuity. Okay, find all the points of discontinuity. So we need to find at what values of x the function is becoming discontinuous. So we need to find the x value, those x value for which the function is becoming discontinuous. Okay, again, so this function it's take different values depending on x, right? So when x equals to 1, the f of x value is 0. When x is less than 0, and the f of x value is x plus 2. When x is greater than 1, x minus 2. Again, this same like a modulus function we are going to do in three cases. Let's say case 1 and case 2 and case 3. Now case 1, when x equals to 1, right? So we need to see the continuity at x equals to 1. So to show that, we need to find the limit, right? So and when x is very close to 1, so we have a different value. When x is very close to 1, which is a slightly less than 1, and this value when x is a slightly greater than 1, we'll take x minus 2. So for this question again, we need to find left hand and right hand limit. So limit of f of x when x is very close to 1 from the left, limit x tends to 1 negative, very close to 1 from the left means when it's slightly less than 1, so we need to take this value x plus 2. So it will be when we just take the x value, it becomes 1 plus 2 equals to 3. So left hand limit is 3. Next, limit the f of x when x is very close to 1 from the right. So that means x is slightly greater than 1, so we have to take this value. Limit x is approaching towards 1 from the right, so x minus 2, right? For right hand we need to take this, and then we take x value as 1. 1 minus 2 equals to negative 1. So here we can see that the left hand limit is not equal to right hand limit. Okay, since the left hand limit is not equals to right hand limit, therefore we can say that this f of x is not continuous at x equals to 1. Therefore, since we have already discussed the definition, right? So f of x is not continuous at x equals to 0, and this is the point of discontinuity. So x equals to 1 is the point of discontinuity. Now we're going to check for all the values of x which are less than 1. Next case. Okay, next case 2 is when x is less than 1. So when x is less than 1, those numbers which are less than 1, so there are infinitely many numbers less than 1, so we don't need to check for each and every number. So for that we are going to take any arbitrary number. So let's take any number, say c, which is less than 1. So we're going to check the continuity at c. So if it is continuous at c, then the function is continuous for all the real numbers less than 1. Okay, so we're going to find the limit of the f of x when x is very close to c, and which is equals to a limit when x is very close to c. F of x value will take as when x is in the c value is less than 1, right? So when x is less than 1, we have to take x plus 2. So when x is very close to c and the c is less than 1, therefore the f of x value will be x plus 2. Now when x is approaches towards c, then this value of the function will approach towards c plus 2. Okay, next we have to find the f of c value, right? F of c. So f, the function will be, again, since c is less than 1, we have to take the function as x plus 2. We have to take this function, right? X plus 2. And since the c value you should be taking as c, the x value should be taking as c, therefore the function value will be c plus 2. Okay, now here we can see that the left hand, that the limit of the function when x is approaching to a c is also equals to the f of c value, right? Therefore, since limit of f of x when x is approaching to a c is equals to f of c, therefore f of x is continuous for all values of x less than 1. Okay, now case 3, when x value is greater than 1. Again, there are infinitely many x numbers and infinitely many numbers which are greater than 1. So we don't need to check for each and every number, so we can take arbitrarily any number. So take any number, let's say c, such that the c value is greater than 1. Okay, so as I told you before, we're just going to check whether the function is continuous when x is approaching to a c, and c is nothing but greater than 1. If the function is continuous at c, then it will be continuous for all the values of x greater than 1. Okay, again, limit of f of x when x is approaching to a c equals to limit x is approaching towards c. Okay, now here, when x is greater than 1, we have to take the value of the function as x minus 2. Okay, so keep in mind. Okay, so when x is greater than 1, the function f of x will be taking as x minus 2, right? So x minus 2. So when x is approaching to a c, and c is nothing but greater than 1, for that we have to take the function as x minus 2. Now when x is approaching to a c, this function will approach towards c minus 2. Okay, now next we have to find f of c value. So the function is nothing but x minus 2. So the function, when x is greater than 1, the function is x minus 2, right? So we have to take this function f of x equals to x minus 2. Now in the place of x we're going to put c, right? So f of c, it will be equals to c minus 2. Similarly, we can see that the limit value is equals to the value of the function, right? Since limit of the f of x when x is approaching to a c is equals to f of c, again we can say that the f of x is continuous for all x which are greater than 1. Hence, we can say that the point of discontinuity, is x equals to 1. So x equal to 1 is the only point of discontinuity. So there's only one point where the function becomes discontinuous. So this x equals to 1 is the point of discontinuity. Okay, now here are the 4 points we can say, and you can also prove that every polynomial function is a continuous. So you can take any polynomial function, let's say x cubed plus 3, or you can write 2x plus 4. So every polynomial function will always be continuous. And also every rational function is continuous. Rational function means x squared plus 2 divided by 2x, or you can write x plus 2 upon x minus 2. So these are rational functions. So every rational function is also continuous. And sine function, right? You knew that sine function. So this is a sine function, and sine function is also continuous, and cosine function is also continuous. And so far, this is all about the continuity of a function. Thank you.